Hello everyone, I am Abid Shaha and today I am going to represent one of the paper which one is this optimized detection and classification on GTRSB dataset, advancing the traffic sign recognition with convolutional neural network. So now I am going to present uh, this. So here is my introduction, and so the paper description is here. You can see the paper from this link, and it is published in last year. So the authors names, and it already cited by three. You can check in the Google Scholar. So here is our introduction. Traffic sign recognition plays a critical role in autonomous driving and ADDS system. Traditional method often struggle with accuracy under real-world variation. CNN has is a most powerful tools or algorithms which actually can extract the different kind of features from a image and make them very crucial to train a dataset. It is very crucial to train a dataset. Okay, so what is the motivation? So motivation is actually there are uh, in the real world we have the autonomous driving, and these are not so much accuracy like in big city. They cannot still they are still struggling. So traditional method like HVM handicrafted features are lack of robustness in real world conditions. So we need actually high accuracy and the real time detection and generalization. So for this region, authors actually write this. Uh, so what is the objective? So the objective of this paper is apply a CNN based approach for traffic sign detection and classification. So they actually want to achieve more accuracy in this GTS RV dataset. Okay, uh, so here is the dataset overview. GTSRV means German Traffic Sign Recognition Benchmark, and there are almost 50,000 images, and the the class level are almost 43. So what is why this dataset is special? Because this in this data set there are many variation in lighting, and something like they have different shapes, partial visibility, and the camera blur. Okay, so for this region actually the data set is they choose, and they split actually the training dataset sample in 80 by 20, which means the training samples are almost 39,000 and testing samples are almost 12,000. Okay, so here is a overview of methodology. They actually use the raw images, and they actually pre-process the data. For pre-processing, I will go to brief it in the next slide. And after pre-processing, they actually split the data in training dataset and testing dataset. And for the categorical features, they actually use the hot encoding, and After that, they applied the CNN and found the evaluation. Okay. So in the data processing, the images are resized into 32 by 32 or 48 by 48 uh, pixel. So after that, they actually the pixel values need to be normalized. Otherwise, it will not trained well, as we all know that. So for that reason, they actually divided it by 255 maybe, and they actually found the scale between 0 to 1. Okay. And for the level, they use the hot encoding for the categorical catastrophe loss. Okay. So here is some data argumentation which actually use for improve generalization and simulate real world driving condition like rotation, zoom, brightness, contrast, variation, transaction, noise injection, uh, like this. Okay. So in the model configuration, they actually use three layer of CNN and two fully connected neural network. And for the activation function, they use the ReLU for nonlinear functionality, and they use the dropout, and the optimizer was used by them, which one is Adam optimizer. And for the categorical cross constropy, they found the loss function, and they uses the base size is 32 or 46, and approaches which almost 20 to 50, and they actually can be stopped earlier. Okay. So they actually split the data, training data, and split from training data 80 by 20 or k fold. Okay. For validation. So here is the conventional layer map which actually they use to feature the map generation. Okay. And here is the for reduce the size and retain feature, they actually use the uh, pooling layer. After that, it goes to the after that they actually use dropout layer. Here is the uh, mathematics, and they use it for the prevent the overfitting. Okay. And here is fully connected neural connected layer. The mathematics is like this. The equation is here. You can have a look. uh, so it is the flow diagram. Okay. So here we can see, we can after pre-processing the data, the here is the input layer, and it goes to the convention layer and extracting the feature here. And after that, they uh, pull it, use the pull method, and after that they actually send it to the fully connected neural network. And after that, they actually make it one by one and get the output. Okay. So the summarize of the methodology is acquire and analyze the data set, pre-processing like resize and normalize, and after that they use the CNN architecture and train and validate and test on the new signs that are similar to them, and they actually found the uh, predicted class and probability. Okay. So the testing accuracy is 95.95%, which is quite good, and the strong generalization across varied signs. Loss or accuracy graph shows stable coverance, and performance across signs shown in the category wise flowchart. So here is the figure 7 where we can see the class wise accuracy. So here we have end of the limit 80 kilometer. Its accuracy is 80% actually, and something like general caution which one is 82%. So this most of the cases they actually passes the result, uh, shows a good accuracy. However, in some category they might have not a good accuracy. So what can be the reason behind it? So if we after read the paper, I feel that there might be have some problem in the data sets which actually have not enough data set. So for that reason they might not be well trained for these classes, for this class, for maybe this class, and the rest of the part is quite good. The accuracy is good. Okay. So classification report, so I already talk about it. However, so in the conclusion we can say that in the future uh, we can they can work with the larger dataset, and real-time video integration, like if we give if they can train the dataset with the video, then it might be more accurate. And architectural improvement like deeper CNNs and ResNet, they actually suggest here. So that's all. Thank you guys. If you have any question, you can ask me in later in class maybe. So thank you everyone.